I just unshared it, and now we share again. I have to. Okay. Can you see the presentation?
Yes, we can see.
Okay, good. So I will start. So thanks again. So this will be a presentation just for Google Earth Engine, an introduction based on what we discussed yesterday. So we are going to use Sentinel-2 data, and we are going to apply different classifier. We would start with cards, so it will be a machine learning, but we can play with other among the one available, like random forest, for example. It's up to us, to be honest. As you remember, yesterday I mentioned, if you prefer, you can write in the chat in the meantime. We can share already the material. I was planning to share at the end of the course, but if you want, I can share already today everything we have, in case you want to go back and see some of the stuff I presented already. Again, these are the objective of the course, so you are hopefully already familiar with. I'm going now to the framework of the presentation. So introduction to Google Earth Engine, the code editor platform, so the one we are going to do a little bit of coding, and yeah, showcase some of the available resources. As you can see, I took some of these slides and images from other people presentation who are acknowledged at the bottom. So what is Google Earth Engine? It's like a GIS platform, which of course has the huge benefit of giving you access on data, satellite data. So you don't need to download the data. And you can see it's a huge amount. We are talking about petabyte of public data catalog. Of course, we are interested in just to Sentinel, but still, even only Sentinel, it accounts for alone for already for several terabytes of data. And it's a cloud-based geospatial processing platform. It means that we can use cloud computing processing system. So we have a huge RAM power to process the data. So these, I think, are the two main benefit, game changer for Google Earth Engine. We have access to data, huge amount of data, and we can process with a cloud computing system. Of course, it's interactive, so we can create, share our own code, and save. And of course, we can also share this code of different platform. We can, for example, create a code in, it's based on JavaScript, but of course it can also be with some changes also adapted to other programming languages like Python, for example. So it's quite flexible. This is just to give you some numbers. So we have at the moment more than 5 million images and more than 33 years of satellite data. So you remember yesterday I told you about the benefit of using satellite data in general. We can do retrospective studies. So even if something happened today, we want to know what if there was any correlation with something occurred 10, 20 years ago, we can do it. We have more than every day 1,000 of images. You see 4,000 from MODIS, Landsat, Sentinel. It's not just Sentinel, okay? Also, in addition to the satellite imagery, there are other public datasets, like, for example, DTM data. And yeah, in total, we are talking about, at the moment, 5 petabyte, which is a huge number. So it allows to analyze things at planet scale. This is the second benefit. So the first is the huge amount of data we can have access to. The second is, of course, the computing power. So as you can see how it works, we essentially use the Google facilities. So we are talking about cluster of thousands of computers, of servers. What happens is, for example, if we want to process the United States in 1 second, we create our own code, we run the code, and what the computer does, what Google Earth Engine does, is essentially splitting the area in smaller area, okay? Each processed individually, so it's a parallelized process, and then all these grades are merged again. Okay, so this makes, and this is important, Google Earth Engine very powerful for raster calculation. So for dealing with raster there is no other facility, probably Amazon Web Services, similar in terms of power. But of course, for example, if we talk with vector data, is not ideal, analyzing vector data, just because this issue of splitting data and merging them again. I'm trying to go. Okay, so we have two options. So on the fly. So as I told you, we can run instantaneously, we can visualize data, which is important. For example, in Google Earth Engine, I don't know how many of you are familiar with debugging code. So MATLAB, Octave, so also Python, Spider. We want to analyze where the error is. We have to debug. So we have to stop the process at some point. Sometimes it can take time until we arrive at that line of code where we think there is an issue. So with Google Earth Engine, we cannot do any debugging at the moment. But of course, we don't have to wait long, because even if we run a long process for a large scale analysis, it will be instantaneously. So we can check any issue and update any line of the code instantaneously. We don't need to wait minutes before the code is arriving at that specific line. And then, of course, we can also have batch computation, so parallel computation. Essentially, we run a loop, okay? And we want to do that process for different times or different areas in one go. Let me. Two platforms. So the one, let's say, I would say for beginners is the graphical user interface, which is, you could click here. I will forward this presentation probably straight away. So this one essentially is for visualizing data. It's very user-friendly, and yeah, as I also wrote here, it's just for explore, visualize data, interrogate data, query data, that's it. You cannot do any let's say you can do simple calculation, but not develop full coding or classification analysis on it. What we're going to use is this other platform, the code editor. So it's powerful because it allows you to have also complex script. Of course, requires some programming knowledge, but very minimum. And also the benefit of Google Earth Engine is, for example, even the example I'm going to show you today, it's essentially something that I took from internet, from YouTube. So most of these things, if you are in trouble with a specific function, the use of specific function or methodology, you can probably find this, the solution online, because someone else has already done it eventually. And again, this is the benefit that supports both JavaScript and Python with this other Google platform called a Colab. So essentially Colab is a platform where you can run Python code, and because it's Google, it's also, you can connect to Google Earth Engine. So essentially what happens is, for example, you want to do some big calculation, you use Google Earth Engine, but then you want to do other type of calculation on that data set, you can then go in Google Colab. But of course, if you are using Python, if you need to use Python code. So this is, it's a very short presentation, by the way. So this is the first of the two platforms I told you, the graphical user interface. So as I told you, you can point and click, and it's mainly for non-programmers. So you just upload data already there. You don't need to do anything, and you can essentially do everything you could do eventually in raster calculation. That's it. This is how it appears. And of course, once you register with Google Earth Engine, you have access to both. The second one, so what we will see today is this, the Earth Engine code editor. So this is a screenshot from my Google account. So you could see this is my face. So I have access with my Gmail. So this means, for example, and we will discover today, even the output, they are all connected to your Google account. So for example, you save the output in your drive, for example, Google Drive, and you can share with other Gmail account. You can, of course, create your own code here. So this is the essentially the main window. We will see in the next slide. Here is where you write the code, and you can share this code with other people. You can give right and permission to write, edit, or just visualize. And yeah, so this, you can see here, these are the script I created, my script. And some of them, you see, these are the card classification I'm planning to do. Yeah, this is just with all the details. So we have always the map at the bottom with some geometry tools. We are going to use some of these geometry tools today. This is, yeah, layer. So it's like with Google Maps, you can just show the satellite imagery or the roads. And so, of course, it's important you have internet. Otherwise, you cannot do anything here. You cannot work offline. These are three windows. We will discover all of three of them. Script is essentially your script, where script you created or script you have been giving access to. Docs is essentially the API documentation. So if you have issue on how it works, some specific function, you can find, yeah, the information here. The asset manager is essentially, and this is why I share with you this zip file today, is where you can upload stuff, material. The problem is you can upload up to at least 4 people with a Gmail without any premium or paid subscription. You have a maximum of 10 gigabytes of data, if I remember correctly. In any case, there is a limit. So you could upload eventually also high resolution imagery. But of course, they will probably fill up very soon, your asset manager. So here in our case today, we will upload just shapefile to delimit the area of interest. Here, yeah, you can search for dataset place, like a normal Google search. This is the code editor. You do everything here. Then you can get links you can share with other people. You can save, of course, and run the script. As I told you, there is no option to debug. The only help support from the code editor is they give you some warnings if they think there is some problem with the syntax of the code. And then here, yeah, you have the main is the console. So essentially here will be printed everything from error or to results, diagram, and everything. Inspector is where you can essentially interrogate the results you have here of all the layer you decide to upload, because this layer at the beginning is just your yeah, the map, the background map. But then if you have some output from the code editor, it will be uploaded here. In that case, once you have the layers here, you can interrogate with the inspector. And task is essentially when you have the output. So if you have stuff you want to download, export to your Google Drive, you need to then go in task. Yeah, I think that is a very short presentation, but just because I would prefer now to check everything, as I will stop sharing and stop recording.